Okay, so another mandatory proof. We need to prove that sine of A plus B is sine A cos B plus cos A sine B. Okay, and to do that we're going to use this, which we've proved already. So cos of A minus B. Okay, now we're looking for sine of A plus B. Now we know that sine of A is the same as cos of 90 minus A. We want sine of A plus B, so that's cos of 90 minus A plus B. Okay, but in order to do that, we're going to replace, and this is just a little note to yourself, this is how we do it. We'll replace A with 90 minus A. Alright, so we're going to use this, but instead of A, we're putting in 90 minus A, because that's going to allow us to get to here. So instead of A, we have cos of 90 minus A minus B. Okay? Now, what we actually have here, I'm just going to keep going on the left for a minute. Okay? What we actually have here is cos of 90. Now, I have minus A minus B, so I can factorize out the minus, and then I end up with A plus B. So minus A minus B. Okay, factorize out the minus and I have 90 minus A plus B, which is exactly what I want, because I know cos of 90 minus A plus B is sine of A plus B. So that's how it's going to allow me to get the sine on the left hand side. Okay, now let's just fly back up here. What I've said is I'm replacing A with 90 minus A. So anywhere in this formula I have A, I'm replacing it with 90 minus A. Okay, so what we have here is cos of 90 minus A, cos B, and sine of 90 minus A, sine B. Okay, now cos of 90 minus A, I literally just rubbed it out.
Why does it go from sine to cos and then cos to sine instead of staying all its cos on the other half of the plus? Yeah, on this side, yeah.
I'm using this. Okay?
Oh, okay.
So all I've done is, in this box, I've replaced A with 90 minus A everywhere. So 90 minus A there, 90 minus A there, and 90 minus A there. Okay?
Oh, okay. So
that's
you're
all.
not staying with the original
No.
to prove that.
This I don't use. I have to use what I already know. What I already know is the box. Okay? And I'm trying to change the box in such a way that I'll end up with the question. Okay, so you start with your box. I've learnt I need to replace A with 90 minus A. Okay, and that's all I'm doing in this scenario. 90 minus A minus B, 90 minus A, and 90 minus A. Okay, now here on the left, what we said was we factorized out the minus, and I was left with A plus B. And over here, let's just figure out what each of these things are. So we said a minute ago, cos of 90 minus A is the same as sine A. So replace that with sine A, cos B. Okay, and also something else we learned the last day. Sine of 90 minus A is cos A. So I've sine of 90 minus A here, so I'm going to replace that with cos A, sine B. And your last step, which we've already actually done, we've said cos of 90 minus an angle is the same as sine of the angle. So cos of 90 minus A plus B is sine of A plus B, and I don't need to do anything else except write that out. Okay, so I've that proven now. Few things you need to remember is you're replacing A with 90 minus A, and then you go to your log tables and you use these. Okay, so they are, again, Oh no, they're not in your log tables actually, they're the ones you need to learn. Okay, so learn. So that's a mandatory proof. This is literally what you put on the page, okay? The sign of A, number 11, this one is not mandatory, okay? To prove sine of A minus B, you're actually just using your answer from above, but instead of B, you're replacing it with minus B. Okay, so you're using your answer from above, so I'm putting my answer here in a box because this is what I'm going to use. And anywhere I see B, I'm replacing with minus B. So your little note to yourself. So I end up with sine of A minus B. And anywhere I see B, I just put minus B. And then you go to your log tables. And you know cos of minus A is the same as cos A. So that cos of minus B will just be the same as cos B. Okay, so sine of A minus B. Cos of minus B is the same as cos B, so that's just cos B. And sine of minus B, if you go here, sine of minus B is minus sine B. Okay, so sine of minus B is minus sine B. And there you've approved. Okay. Now, we've one other mandatory proof in this section. Any issues with that?
Does a mandatory proof mean it's not in the it's in the log tables?
No, a mandatory proof means you have to learn off how to prove it. Okay?
Okay.
So it's something they will ask you, they will say, prove this. So you have to learn off this method, whereas down here, they're not asking you to learn it off, they just want you to be able to use it.
Oh.
Okay? So, number 12, we now have to work with tan. Can I get rid of the board? And tan is one we have to learn off by heart.
Miss, did you say for the last one we need to learn that, sorry?
Number 11, no.
Or
Okay, prove that tan of A plus B is tan A plus tan B over 1 minus tan A tan B. Anyone any ideas on how to start this?
replaced with sine and cos?
Yeah, exactly. You know that tan is sine over cos, so you're going to replace it everywhere with sine over cos. Okay? So what we end up with is tan of A plus B is sine of A plus B over cos of A plus B. That's on the left. And on the right we have tan of A, which is sine of A over cos of A. Sine of B over cos of B. 1 minus. Okay, I'm just replacing any tan I see with sine over cos. Now, what we're going to do is sine of a plus b is in our log tables. Okay, so we've proved it. We just did it a second ago. So that's sine a cos b plus cos a sine b. So let's replace that. Okay, so instead of sine of a plus b, we're putting in this. Sine a cos b plus cos a sine b. Okay, and instead of cos of a plus b, we've just proved it, we're putting in this. Okay, cos a and that's equal to this on the right. Okay. Now, if I want the left to look like the right, I need to have a 1 here, because I have a 1 here. Okay? Now, in order to get a 1 here, I'd need to divide this by cos A cos B. If I'm going to divide this by cos A cos B, I have to divide everything else by cos A cos B. Okay, little note to yourself. Divide everything by cos A cos B. Over here. Okay, so what I'm going to be left with is sine A cos B over cos A cos B. I'm dividing absolutely everything by your cos A cos B. Okay, so I just put absolutely everything over cos A cos B, and things are going to cancel. All I'm doing here, I'm just rewriting this side. So all I've done is I've rewritten that, okay. And now, if we just look here, cos B over cos B, they'll cancel. Cos A over cos A, they'll cancel. Cos A cos B over cos A cos B, all cancels. Okay, so what I end up with underneath this is sine A over cos A plus sine B over cos B all over, and this is 1 because it cancelled away, minus sine A sine B over cos A cos B, and that's exactly what I had here. So I've proved it. Okay, so you're just using all the proofs that you did before. So these are what you've learnt before. And then you need to get a 1 on the bottom left. So you divide everything by whatever's on the bottom left there.
How can you divide one side but not the other?
Because I'm actually proving something. So this isn't an equation where I'm moving from left to right, okay? It's actually two separate expressions. So I'm dealing with one, this is one thing all on the left, and this is one thing all on the right, okay? So whatever I do, I have to do to the top and the bottom of this side, okay? So that's why I divided everything on the top by cos A, cos B, and everything on the bottom, and it doesn't change it. Is that okay? So we'll just do 13 next. Okay, so number 13 then, not mandatory, it's just you're using, okay? So now we've tan of A minus B, and we're just using our answer from above, okay? So that's what we proved above. In this scenario, I have minus b, so all I'm going to do, note to myself, replace b with minus b. So anywhere you have a b here, we're going to put in a minus b. And then we're going to go to our log tables, and we're going to see what is tan of minus b. And if you go to your log tables here, you can see tan of minus b is the same as minus tan, okay? So now, anywhere you have tan of minus b, you're just going to change it to minus tan b. Tan A minus tan b. And then that's minus tan b, so minus by minus is plus. And that's what they asked me to prove there and there. Okay, now we need to do a few examples of how they might ask that in a question. So not the proving part, how they might ask us to use these identities. Okay. Can I get rid of the board? Okay, express in third form. Sine of 15 degrees. Okay, now if they really wanted to be particular about this, they'd say without using a calculator. Okay, so what we have to use is sine of two angles. And generally, the angles we're used to are 45. Do you remember we did these in Trig 1? 30, 45 and 60. And we had our little triangles. So we had our equilateral, this was 60, this was 30, 1, 2 and root 3, okay, and we had our isosceles, 45, 45, and we had 1, 1 and root 2. Now all of those angles are actually given to you in your log tables as well, so page 13 of your log tables. Okay, so if you're interested in 30, 45 or 60 degrees, you just go here, 30, 45, 60. So basically what you're going to do is you're going to get 15 using a combination of these three. Okay, so really I'm interested in sine of 45 minus 30, aren't I? Because that will give me my 15. Now, sine of A minus B. Go to your log tables, write out the formula for sine of A minus B, okay? Sine A cos B minus cos A sine B, okay? So if I want sine of 45 minus 30, what I have to do is, A is 45, B is 30. Sine of 45, cos of 30, cos of 45, sine of 30. That minus in there, it's not that minus 30 is the angle. It's your formula is A minus B, and you're just using A and B. Okay, so it's 45 minus 30, you're just using 45 and 30. And then all you do is you go to your log tables and you find out what's sine of 45. So sine of 45 is 1 over root 2. So you write that down, 1 over root 2 by cos of 30. Cos of 30, root 3 over 2. Minus cos of 45, 1 over root 2 by sine of 30, a half. Okay. Just tidying that up, top by top, bottom by bottom, top by top, bottom by bottom. They're both over the same denominator. So you have root 3 minus 1 over 2 root 2. Now if they've told me I'm not allowed to use a calculator, I can either leave it like that or I can rationalise the denominator. So to rationalise the denominator, I'd multiply it by 2 root 2. Root 3 minus 1 over 2 root 2. Okay, the calculator will give you that answer back. Now, they've just said in third form. That is in third form. But if they asked you to rationalise the denominator, you'd multiply the top and the bottom by 2 root 2. Okay, and then you'll end up with no third on the bottom of the question. Okay, this would be rationalising the denominator. Okay.
Wait, Miss, what are the triangles about?
We did them in Trig 1. Okay, so it was a way to find sine, cos and tan of these three angles using special triangles. Okay, so you can go back to Trig 1, it's definitely in your example copy. But you don't need to use the triangles because they are all given to you in the log tables. Okay, but it's just to note that's where they came from. Okay, let's just do one other example. Okay, if tan A is a quarter and tan B is 3/5, find the value of A plus B without using a calculator. So I'm interested in finding A plus B. Go to your log tables and see what identities have A plus B. Now, these have tan, so really you're going to the tan. Okay, so write out your identity. Tan of A plus B is tan A, tan B, 1 minus. Okay. So tan of A plus B, instead of the tan A and the tan B here, I'm going to replace it with my numbers. So a quarter plus 3/5 over 1 minus a quarter by 3/5. Okay, all you're doing is replacing the tan A and the tan B with what you actually have for tan A and tan B. And when I throw that into my calculator, I get 1. Tan of what angle gives you 1? Come back here, we're looking at tan and we're looking for 1. So my angle is 45 degrees. Okay, so A plus B would be the inverse tan of 1. Now I'm not allowed to use my calculator, so I go to my log tables and I look for 1 and I know that that's 45 degrees. Okay,